Hello, my name is Andrei Arguedas and I'm going to show you my prototype for visual attention driven dynamically changing virtual stars. Let's start. Here we are in our virtual reality project. This project was implemented with Unity, and in here we have assets such as dresses, pants, shirts, and bags. So we are going to interact with them to model the user experience for our prototype. First, we are going to define visual attention as a mechanism to shape what we see and allow for concurrent selection of relevant information and inhibition of other information. We are using a head-mounted device to obtain user's eye tracking data. With this information, we will be able to model the user's visual attention on the VR scene. For this prototype, we will be modeling the visual attention or the eye tracking data with the left lightning. So let's suppose that this user focus its attention in dresses that are long and also with opaque colors. So he's more interested in conservative looks. So basically he's ignoring dresses that have too colorful patterns or too shiny colors. So he's mainly focusing on opaque colors and conservative designs. Also, if we see the brands, we can see that some of them are more pricey than others. So let's generate a heat map to understand what this user focused its attention. The heat map will look like this. Basically, the blue ones received less than 200 milliseconds of visual attention, and then we have a scale, so the yellow ones received more and the red ones were the most visually attended. So with this, now we have data to send to our regressor model. So we can also see that he put more attention on the pricey brands and ignored the most cheap ones. Let's reset the heat map, and let's suppose that the user goes to another area and start looking, but goes back and our regressor model will change the recommendations for this section. So now it looks like this. As we can see, now we have more opaque colors with more long dresses, more like a conservative look. So now the user might be more interested. Also, those brands were replaced as well with more pricey ones since it looks like the user likes them. So now let's go to another area. And in here we have bags. So let's suppose that the user starts in here, and with bags this user is the total opposite. He likes shiny bags with modern patterns. So he goes here, and also he goes up and start looking at those ones right there. Also he sees that this section has like opaque colors, this one as well, so he's not interested in that, and he keeps focusing its attention on more modern or more designer bags. So he is totally focused on those ones, right? He goes here and continue looking these modern bags. So similar to the dresses section, let's see the heat map. So we have something similar. We have two sections full of blue with non-visual attention gain, and we have this section full of reds, yellows, and greens, and this one as well. So our regressor model will do the following. Our model worked in the following way. First, we retrieved the data from the valid visual attention to create a heat map to represent this valid visual attention on the products. With this, we send that data to our already trained regressor model, and it will give us a list of recommendations to replace the least visually attended products with products that will match more with users' preferences. We will reset the heat map, and let's suppose that the user goes here to explore this area, goes back, and the regressor model will totally change the less visually attended products. So now in here we have more colorful patterns, more modern ones. Also, the brand is totally new and it's more adjusted to the prices that he likes. And in here we have more shiny styles. So this is how our model for visual attention dynamically changing virtual stores would look. Thanks for watching.